Draft science video. Yay. So not much to report. Oslo Day made a really tedious, boring video about discrete space and whatnot, and yeah, there's not much to do with that. And Piro has made a video, and again, it just talking about how space does this and space is doing that, and space has all this hardware in it now. And at the very end of the video references me in this sense of somehow I shouldn't be derogatory or complainy. I'm too complainy about the integrity of physics in general as a science, and the integrity of the physicists. And this is in the context of, like I said, I've repeatedly referenced people like Feynman, who kept saying things like, don't think about it, just do the math. Don't react to the fact that it all sounds like a big pile of steaming shit. Just play with the shit. And now they've built a whole new pile of shit on top of the pile of shit. And they're just layering piles of shit, and that's how you get to this crap where they start talking about holographic universes and multi-dimensions and all this other crap, is because they just totally leave the building. And yeah, it's way past time for somebody to raise their hand and say, wait a minute, isn't this getting a little bit too fucking wacky? I mean, you're building shit castles in the sky out of shit. And there's gravity, and the shit's gonna fall on you eventually. But this isn't. You got it wrong, and you're just making the wrong. You're just multiplying wrong in your equations. Wrong times wrong times wrong divided by wrong. Factor in the matrix of the, singularities, left foot, blah blah blah, times lambda, double lambda, lambda, lambda. Wrong, wrong, wrong times wrong. I mean, it's just bullshit. So yeah, somebody should say that, I think. I mean, it's obvious bullshit. As soon as they start talking about photons reading your mind, somebody in science should have said, wait a minute, I think you've all left the fucking building. So anyway, so this is just notes I've just taken over the last couple of days. Been thinking about some different things. Thinking about how to word it, diagrams again, in the sense of just diagramming the simplicity of the formula here, the outline, and get to it. There are a couple of comments in my video, but they're just useless, absolutely. These people are crazy. They critique my theory with nothing. Right, I mean, no response to anything in particular said, and they just keep talking about how they have proof of something. What in Mendham doesn't get is that Rotherstism-Burton experiment, 1991, well, I can't find this experiment anywhere, disproves his electron-photon theory. And then it starts bringing up leptons and all this other crap, and you're just, you didn't disprove anything, it doesn't do any of that, you're just making this shit up, asshole. I mean, first you have to actually present me with a link, some kind of theory, some kind of statement somewhere, not something I look up on Google and I just get a bunch of Burton movies or something. I mean, at least have an experiment that I can actually find, a Wikipedia page on it, minimum. You crazy ass. Well, anyway. Yeah. So he's got this whole, bullshit lepton theory of the universe and neutrino bullshit and all this, and you're just like, a neutrino-based universe. A synthetic particle that, exists for hundreds of milliseconds, yeah, that's the universe. So, I mean, the first thing to say is, I circled, smashing is not dissection. So the first thing physicists should have realized is smashing particles probably isn't a great way to dissect a particle. Okay, hitting a frog with a sledgehammer will gain you some information about frog dynamics. I mean, certainly you'll see some guts fly out, some shit'll fly out, and you'll say, gee, there's lots of parts in there. But it's not going to be a very good dissection. It's not going to really give you information about how exactly frogs work. It's just not, you just got to be a little careful using sledgehammers as goddamn dissection tools. It's not a very scientific tool. That's all. It's not a very scientific process. I think the more sensible process would be to, instead of wasting tons of zillions of dollars, if they took 1/10,000th of the money they've wasted on these accelerators and spent it on doing the two-slit experiment rigorously to figure out what exactly is going on, that would be a better way to spend the money. You'd learn more about photons and electrons by doing that than your smashy smash bullshit. So anyway, so what part to get through first? I mean, I guess I'll do this part that's circled first. So I have been, thinking about the lensing thing, Einstein. I mean, it's just a weird connection. I don't see really how this proves Einstein's relativity theory. And it's just this, the fact that light has mass should be obvious. I mean, E equals mc squared. I mean, obviously energy is converted into mass. And what's the difference? Oh, the difference is the mass is circular. So I've sort of made this point, but yeah, the only thing different between the mass of matter and energy is the fact that the energy is circular. It has no direction when it's trapped in matter, and it does have direction when it's energy. So, but it's obviously still the same stuff, theoretically. And yeah, so I mean, the fact that light could possibly be manipulated in a gravitational field, yeah, and I'm arguing that I think, I mean, the thing to find is that the thing, it just takes so much work to go through all the original, to find the original research that validates or invalidates something. So, I mean, looking at some of the documentation for the Einstein lensing effect, you find that in that solar eclipse there was a sun that was at least one sun's diameter away from the sun. Okay, so they were using a star, quote unquote, a sun that was more than a sun's diameter away. So the lens was fairly large around the sun, and so I'm saying, well, obviously it's not the escape velocity of the sun that's doing the diffracting, it's some distance away from the sun, a whole sun's diameter away from the sun, that there's still enough gravity to create lensing. So I'm saying there must be lots of places in the universe that have more gravity than a sun's diameter away from the surface of something. I mean, you'd have lensing everywhere, it seems to me, in the sense that there should be lots of places. I mean, what, half of like the Milky Way galaxy should be lensing, because you would think that halfway in towards its center you must have a gravity that's pretty substantial, I would assume. I mean, I don't know, I have to find that out. But and my argument is that all gravitational bodies are going to have this point in the gravity where there's the event horizon or whatever. I mean, not where light can't escape, but where the matter has to escape. It needs a certain velocity to escape velocity. So they all have that place on there somewhere. And that there's tons of stuff, like a sun is producing a ton of crap is flying out of it, not just photons but little pieces of atoms and all kinds of shit, and it spews out of it in these big huge plumes. And a lot of that stuff ends up not reaching escape velocity, so it has to come back down to the sun. So there's a lot of stuff moving in that field towards the sun. It's a rich field of particulates, and I would argue that any field of particulates is likely to create optical diffraction. You're going to diffract light if you put it through a field of particles. And so that would be the explanation of lensing around gravitational bodies. You don't need to bend space, you don't need to do all that crap to diffract light. Yeah. So I mean, the only way, but again, the proof is going to be in the fact that I find some gravitational body where there's not a lot of particulates, because it's not a sun, it's not spewing a ton of energy out, so there's not a hell of a lot of stuff coming back in. And if we don't have any lensing in that clear space, in high gravity with clear space, let's call it that way, if there's no lensing in high gravity where there's clear space, then I think Einstein's theory is less meaningful. Obviously, it doesn't. Obviously, if you have examples of it not applying, it means it's probably not the right answer. Anyway, matter converts to energy. Yeah. So okay. Here's the black hole thing. I guess I'll just do a quick thing on that. They keep talking about the event horizon. That's where the sun. That's where the gravity is. Once you cross the line, even light can't escape. It can't achieve a velocity capable of escaping. So even 186,000 miles a second is not enough velocity to escape. And they talk about it as if and also that time dilates completely, and so theoretically something goes across this event horizon and just stays there forever because it has no velocity anymore, because there's no passage of time anymore. And my argument from my theory is that no, long before anything reaches the event horizon, most of the matter is converting into energy, moving in a direction. So most of the photons of the matter are being re-pointed and re-accelerating. They're all starting to move in one direction towards the center of the gravity. And by the time they hit the event horizon, they're substantially already light. They're already moving very fast, and they're just complete the process of converting entirely into energy, and it's energy pointed at the mass. So of course no light goes anywhere else, is because all the light is pointed towards the center of the gravity. The matter has no capacity to produce photons going some other direction, because all the photons are already going in the direction of the gravity. So that's and that long before you reach this event horizon, the matter has already lost its identity. Long before you get to the event horizon, you will no longer be you. Your matter will deconstruct. You will not be alive. You will not be a functioning material body anymore. The destruction of the metabolism of your atoms will be so substantial that there'll be very little atomic activity that is meaningful. The traps that were trapping your energy will be released in a very systematic way, where the energy is released in the direction of the gravity. Simple. Alright, so the next thing to go to is just this basic diagram. So okay, you just start with the photon, and I'm going to write it up, but I'm getting pretty confident that photons are just photons. They're, as Einstein said, he came up with the word, photon, to distinguish it. It's not some wavy, bullshitty thingy. It's a photon. It's a thing. It's a corpuscle. We're back to that argument. It's a thing. And everybody just keeps talking about light waves. They just keep doing it. Every video I watch, it's all this wave theory. And the wave is a manifestation of interaction. You will not see the wave until you have the photon interact with an electron. But there is no wave in the photon. The photon is a point of energy separated by time. That's the electromagnetic spectrum is just changing how much time separates the photons, the corpuscles of energy, the thing. What the thing is, who cares? It's a thing. It's a discrete thing, a consistent thing, and the only thing you're changing is the frequency, how often in 1 second, how many will impact in 1 second. So photons are the quanta. The arrangement is matter. So as soon as you trap them, and it's just arrangement pattern means trap. And, usually the simplest trap is a circle. It just makes sense, right? The snake chases its tail, and then once the snake is chasing its tail, it's not going anywhere. It's just going to chase its tail until something lets it free. And so the nature of matter is just energy trapped. It's an energy trap. Matter is an energy trap. There's no matter, there's no hardware they're doing it. There's not a machine that absorbs the stuff and converts it into a candy bar or something, and then stores the candy bar in a storeroom somewhere. Matter isn't some device that stores electricity or stores energy. Okay, because we can't find any of the pieces of this matter device. All the pieces break down into energy. You smash them with the smasher and they smash into a certain kind of juice that comes out. Atoms, for like the frog, we could say that atoms are the thing it's made out of. Well, you smash atoms and the thing it's made out of is photons. Every bit of everything that we've found, every particle just about that we've found, you can destruct it completely and all you get out is energy. You don't get anything else. You don't get pieces of the machinery. So anyway, don't want to distract from the point. So your photons in arrangements, in circles, patterns, are trapped, okay, and that becomes matter. So you trap a photon, you connect them together, and you trap them, they're matter. And the matter moves. So the photons are moving in the pattern, but the pattern itself moves. And we call that stuff moving, or velocity, and whatever. But that movement has to happen within the constrictions of the photon still moving the speed of light. So you can't move things without obeying the rule that the light can't go any faster than the speed of light. So it all has to be in the right direction. The movement has to be, again, I've said this before, but there's like a zillion frame rate. And when my hand moves, it's not really moving, in this nice, smooth manner. The matter itself, the photons, are moving in a completely different kind of way. They're going all over the place to get this to here. It just doesn't have. It's within that constraint. But I'm saying there's a million times. So it's like you can have a wavelength of radio waves, let's say, and the wavelength, the time between photons, can be a mile of distance. But a mile of distance is still 186,000 times a second. You get it? It's moving the speed of light, you see? So it's 186,000 of them per second. So obviously there's a lot of stuff you can do in that second in terms of changing the intensity or the amplitude of the signal. So even photons that only come one every mile of distance, there's still a hell of a lot of them in 1 second. Yeah, that's how fast light's going. So anyway, so we're to this movement thing, and so that creates this distance thing, velocity, and time. And the point is that the atomic movement, the movement of matter, creates rearrangement. So the matter has arrangement. It's doing a figure 8, let's say, and if you move it, it's got to rearrange the figure 8. It's got to move the figure 8. And these are the mechanisms, that create what's called momentum or velocity inside of something. Inertia is the fact that the pattern has been changed, and the thing now will drift in a direction until something forces it to drift in another direction. So let's say I was in a space shuttle-y thing in some sort of zero gravity circumstance, and I made a looping string that I spun. So let's say I could create a looping string that I could spin on a machine and release the looping string. If the looping string has an irregularity, not a perfect circle but an ellipse, it will tend to go in a direction because of the forces of centrifugal forces. And you could shove it, you could just poke it and it'll go in another direction, or poke it another way, it'll go another way. But it'll just keep doing that as long as it's not a circle. As soon as it's out of round, it will tend to wobble through space. And the direction of the wobble is arbitrary. It just happens to be which way it's pointed. And that's essentially what is the nature of our internal structures, a bunch of atoms wobbling. And they can wobble in one direction, or they can wobble in all kinds of directions. And what decides that are the fields that we're in, the things hitting us. And that's where we get into gravity and magnetism, which I'm saying are created by a stream of pressure that has a gradient that creates gravity by shadowing us from pressure. So it creates a low pressure area on one side of us, and that side of us will tend to the rearrangement will tend to force us to drift that way. So it's essentially poking the ellipses into alignment. So now the ellipses are all pointing in that direction. Because if they don't point in that direction, they're going to get hit by a photon. It's that kind of thing. They're getting hit from all directions, you know, from the three sides, more than they're getting poked from this side. So they're going to quite obviously over time tend to wobble in that direction. That'll be the safe wobble. The tolerable, the accepted, the unchanged wobble. That's where their wobble will stop being rearranged. And that's the nature of gravity and magnetism. And then electricity is added on to that. In terms of that's strictly an electron function. So anyway, that's probably enough of a video. But you know, I'm not getting any counter arguments to any of this stuff. Not just getting insulted. Which is, you know, fine. I mean, I'm insulting physicists. I'm insulting the subject of physics, but at least I'm doing it with some sort of rational argument why this theory is much more sensible than theories of matter is little machines that are absorbing energy, and space is complex arrangements of superpowers where that stretch and widen and create fields of magical dew. Little spots in space of non-nothing that affects the something. When the something goes over the nothing, the something gets changed by the nothing. Yeah, I don't have, there's nothing in my theory that allows nothing to change something. It's purely a something converts into something else, and then those two somethings interact with each other and create this animation, movement, function. But it's all one something. Just as evolution, it's all one evolution. The microbes, the plants, the animals. It all came from one place. They interact in different ways, but it's all one thing. And the interaction is very complex and interesting, elaborate. But it's just this biosphere. It's just a equilibrium that's achieved based on the rules of the interaction. The rules of interaction is mostly, for atomic structure, photons interacting with electrons. That's the 85% of the rules. And the interior structures are all hardware, probably created in the initial Big Bang kind of moments. They're fundamental elements now, but they're just made out of the same stuff. They're just more durable pieces of stuff. And the electrons are more interactive. You can change them easier. Something like that. I mean, clearly I would think neutrons and protons are doing something interesting. But like I said, we don't really need to go there to explain most of the interactions that take place that create most of the things, the phenomenon we call reality. Alright, that's enough. So we're, approaching 30 videos, so probably I will restart when I hit 30. I said that when I hit 20, but I didn't. Just going down the bullet points again. Just like I said, I have to do some writing. It's very, you have to be so careful how you word things. But I'll try to be careful in how I word things. But yeah, it is hard to write physics postulates carefully. Accurate to what can be established as being factual. What's proven and what's not proven, or what's proven by default, in the sense that there's no reasonable, the alternative solution is not rational. I'm just arguing that here we have a perfectly viable photon on photon universe explanation of the mechanics, things reacting with things, and then you have this other theory where nothing reacts with something, magical events take place. I'm just saying by default, the thing versus thing, and until you prove it fundamentally flawed, you have to go with it. And like I said, their old proof wasn't a complete proof. It was a flawed proof. It wasn't a proof at all, is what I'm saying. Quite obviously, the theory of photonic pressure was not given a fair... it didn't fairly transition through the 1900s. And I don't know whether to blame Einstein or not, but, I mean, clearly it was trashed and disregarded for reasons I shouldn't... The reasons shouldn't be so obviously flawed that somebody like me can see them. So the very fact that the disposal method was so crude and unsophisticated, thoughtless, reckless, sloppy, just kind of indicates there must have been a bias involved. They didn't want the truth to be crude. They wanted the truth to be dimensional. So anyway, I think they tend to want to believe in magic. They tend to want to believe photons can read our mind. It would appear, because there seems to be an obvious prejudice towards the non-simple, mechanical answer. Anyway, enough of the video.